What's going on, guys? Simon here, and today I'm going to talk about physics engines. So straight off the bat, what are physics engines? Physics engines are computer software designed to simulate physics within a game, films, or whatever you like. Looking at the video playing now, a physics engine was required in order for the character to properly swim underwater. Working behind the scenes, they are extremely important for making a game with movement possible. Obviously they aren't used much in puzzle games, but they are important for shooters, sports games, platformers, and a whole lot more. Now you guys are probably thinking, oh cool, so how does this simulate physics? Well, the software will take into account many variables, such as the desired gravity level, the surface area of the objects, as well as the speed. The amount the software has to handle is extremely large, with thus why we lazy humans get computers to do it. A vital part of this is collisions. Taking this one aspect, we first need to find out how the collisions will be detected. Will we run checks every frame to see if we're about to collide with an object? Will we move ourselves into a better position after we've collided into the object? Once this is decided, we must decide how we'll land on the object properly. Will we move pixel by pixel in one frame until we reach the desired point? Could we check the distance required to land properly and then move ourselves to it? Although the differences aren't too noticeable, this can heavily affect how it works in other situations. All of this work is done in just one frame. But how long is one frame, you may ask? This is dependent on the game. Some games may have 30 frames per second, but some could go as high as 90 frames, and even higher. Some of you may be thinking, are physics engines really that useful? Can you prove how useful they are? Of course I can. Using a software known as Game Maker, I've created an extremely basic world in order to simulate physics, and in these examples, I'm going to show 4 examples. The first is no physics. It shows what it would look like if a physics engine wasn't created. As you can see, the person doesn't fall, let alone collide with the floor, as gravity hasn't been created. The second example does have gravity set, and the person falls. However, without collision set, the person simply goes past the floor and goes on forever. To fix this, we can set up a collision setting between these two objects, which is shown in the third example. Here the person falls and collides with the floor, causing the character to stop falling. As we add more checks, we begin to simulate parts of physics in real life. Some of you should have noticed though, the person isn't sliding down the slope. The fourth and final example remedies this. After falling and colliding with the floor, the person now slides down the slope until they reach the end, and, once more due to gravity, will fall down. Although these 4 examples give you a better idea of why physics engines are important, there are a lot more things to consider. For example, should a person bounce when they touch the floor? Are they speeding up while falling down or sliding down the slope? Are they moving a certain horizontal distance when they fall off the slope? The list goes on. I guess there's time for one more question. I can see that one of you want to ask, these physics engines seem amazing, but aren't there limitations or problems in their awesomeness? Unfortunately, yes. As physics engines take into account many variables, precision is often purposely decreased, especially in games or virtual simulators, in order to compete with the speed of the game. The only way to fix this is to get a better processing unit, in order to handle all the calculations, and of course this means you need more money. A physics engine is also only as good as the programmers themselves. Problems with bad engines include building up energy which can be released and can cause unnatural movement. For example, 2 balls are falling down a hole and get stuck between each other. In real life, these 2 balls will simply stay there due to friction. However, a bad physics engine may still try to move the ball until they reach maximum velocity, and this could cause the 2 balls to shake violently until one or both shoot off in a direction. This is quite unrealistic when the 2 are compared. This ends my video on physics engines. I hope you guys enjoy your last week of school, and I also hope you get good exam results. Peter, if you're watching this, nice haircut. Alright then, Simon Chiu, signing out.